I'm Gesa. I'm working together with Paul in Sydney at UNSW, and we work on this small algae called Cryptophytes, and we are investigating how they use photosynthesis. And they face one big challenge, which is they live underwater, so they have to be super efficient and use every single photon which they can get, because a lot of them get filtered out by the water. And to be that efficient, they have developed an antenna complex around the light harvesting complex, and by this, they can increase, on the one hand, the area where they can catch photons, but also the spectral range which they can use. And something important, which a previous postdoc found out, is that these antenna proteins come in different forms. And each different form absorbs a different wavelength. And there are two obvious categories of these forms, the open and the closed form. And now when these cryptophytes have the antenna complex, they have a new challenge, which is to transport the energy efficiency from wherever the photon hits to the photosystem. And they solve this very well. They have almost 100% efficiency, so we are wondering, how are they doing this? Are they using classical physics to transport the energy, or are they using quantum physics? And to solve this problems, we can look at which forms of these antenna proteins are used, because so the energy gets transformed in the chromophores in them, and in these closed forms, the chromophores are close enough, so quantum physics can be used as a transfer process, but in the open form, there's this wide gap, so classical physics has to be used. I'm most interested in how does the energy get transferred from the antenna protein, which is closest to the photosystem. So what I'm trying to find out is this the open or the closed form of the protein? And to solve this question, I'm using cryo-EM. So I want to do a picture, basically, of the photosystem and the antenna complex around it. And I want to see which protein is closest to it. And the other questions I want to solve then is there some other overall structure in this antenna complex? For example, are they forming filaments? And if I have those overall structure, then I will use it to produce molecular dynamics simulations of the antenna complex, and then do quantum mechanical calculations of the transfer of the excitation. Yeah, and then I came up with other fun experiments, for example, creating an artificial antenna complex, which you can see at my poster.
Thank you. Great.